I'm going to try to do with this session, just so you know, is talk about some things where we're going between service management and cloud with the concept we call the infrastructure authority, but then also talk about what are some of the building blocks to get you there. Because it's one thing to talk about the target and where some things are going in terms of management and orchestration, but the more relevant piece is really what are some practical things that you can be doing right now from a planning and architecture perspective that'll have you prepared to leverage some of these technologies once they are available. So that's really the gist of what this is about. Just so you understand some of the motivation here, we started thinking about this concept last year when we were looking at some problems customers were having. They were looking at trying to do things with multi-tenancy and doing some security zone isolation, some security zone separation just within the same physical cluster. And what they were realizing was even with technologies like VMware vShield Zones, VMware DRS has a mind of its own. If DRS wants to place a workload somewhere, it only looks at two things. It's looking at available CPU and available memory. If I'm trying to do partitioning at the cluster level, DRS doesn't care. If I have I/O constraints, DRS doesn't care. So if I have site restrictions or data export restrictions or all these other things that could impact where a VM belongs, there's nothing in the orchestration layers that can do that. When I started talking to orchestration vendors about some of these issues, I said, what are you guys doing in terms of, connecting policy to orchestration? And a lot of them said, well, policy based on operational constraints and performance is something they can do very well. But policy based on other areas, such as, again, site-level restrictions, data export restrictions, even the idea when you're thinking about hybrid clouds and moving a workload out to the cloud, right? I have all these other operational stuff that gets tied to that. Besides security, I have operational things like backup. My data might need to be near an array because I have backup, I have a backup window that I need to meet and I have certain RPO requirements. So therefore, just physical location might be driven by my actual backup architecture. So it's not just a question of just putting a VM where the most capacity is. It just doesn't work. Things start to fall apart if I really want to orchestrate things, which right now we're really not. We're doing some automated provisioning, but trying to get into really mobility and really trying to optimize infrastructure dynamically is not something that we have the capacity to do right now. So, the net of it is about infrastructure authority is somebody has to be in charge, right? In my family, the infrastructure authority, I admit it, it's my wife. You don't want me in charge. When dad's in charge, my son says, oh, can I, go swing an axe in the backyard? Oh, sure, knock yourself out. It's just not wise. We need infrastructure authority, at least in my family, is mom. We need mom in charge here. So that's kind of what I'm going to be talking about today. Again, I'm going to get into some of the nuts and bolts as we see how the infrastructure authority plays out in the second half of the presentation. The first half, hopefully I'm not going to bore you with it, is going to be about how we actually build to that, and what are some of the things you should be looking at as you're building to that infrastructure authority concept as you're building out, say, this internal cloud infrastructure. I'm a research VP with Gartner. I handle the tactical research on server and client virtualization as well as infrastructure as a service. So basically that means is that I wind up having to write some long, boring reports that are typically 25 to 50 pages in length. We deep dive on a lot of technology-specific issues as well as some architectural best practices. So that's the kind of stuff that I do. I do a lot of work with end-user organizations, helping them and also listening to them about some of the issues that they're facing and what are some of their concerns when it comes to virtualization and infrastructure as a service. Okay, so things I'm going to be running through here is the building blocks that we see for cloud. And no, I am not going to sit here pontificating over definitions for clouds for 30 minutes. Don't worry, I'll spend about 30 seconds on it and spare you the pain. Internal cloud maturity model, I'm going to talk about that. And that's something that I co-developed with Cameron Haight a couple of months ago, and basically it takes you through a series of 5 phases of maturity and issues that you should be thinking about at each of those phases to prepare yourself for true service level delivery. Because to us, when we're thinking about clouds, provisioning a VM is not a cloud. I don't care what a vendor says. That's not a cloud. That's just, that's very rudimentary IT as a service, if you even want to call it that. A cloud service is giving our consumer a service in an interface that they understand. It's not having to spend time and explain a VM to them. If you're explaining what a VM is to your users, you've already lost. And I mean, for some users, good luck. I've been working in virtualization since 1999. If you ask my wife what I do, she's going to tell you I work on computers. that's as far as I can get with her. I mean, explaining a virtual machine, it's just not going to happen. So, I think my relatives, they think I work at Best Buy, and so I'm the family tech support guy. I've just accepted it. I'm not fighting it. It is what it is. So we're gonna move into the maturity model, get through that, talk about some of those stages. I do full day workshops on our maturity model. So I mean, it's really easily 8 hours of content. I'm going to squeeze it into 15 minutes. There's going to be some stuff unsaid there, but I wanted to try to at least give you some details there. That and again, if you want the slide deck, just shoot me an email, chris.wolf@Gartner, and you'll have that at least for a reference material. If you're not a client of the Burton Research under the Gartner wing, what I would recommend you do is just tell your Gartner account executive that you're interested, and that person will be able to send you the full report that outlines our internal cloud maturity model. It's about, again, 40 pages of technical decisions, practical steps to get there along the way. And again, I don't care if you're interested in the service or not. That's a way to get the free document. So there you have it. And that's why I'm not in sales, and probably why my career trajectory is flatlined right now too. So that's okay. All right, and then I'm going to wrap it up with some practical steps. So we're going to talk about all this future-y stuff, right? Building this infrastructure authority, building this cloud model, and then I want to wrap it up, spend about 10 minutes on what can you be doing today and over the next couple of years to really start getting further down that path towards cloud infrastructure. So what are the building blocks? Here's your typical cloud-tiered architecture. The only real difference I would say that you've probably seen from other definitions is we do split out infrastructure as a service into delivering software infrastructure as a service, such as database services, for example, content distribution, compared to hardware infrastructure as a service, which would be delivering virtual machines, for example, as a service, or any kind of compute infrastructure, whether that be EC2, vCloud, et cetera. So that's what we're going to talk about today. Now, this is, again, something I can't spend, I could spend hours on, but we only really have a little bit of time here. I wanted to bring it up to put things into context. When we talk about cloud, you need to have a starting point or a goal. And what this is something we published last year. This was published early last year after working with several of our enterprise clients, as well as working with all of the major vendors in the space. And we published a reference architecture for infrastructure as a service as being something we wanted folks to aim to when they were building out their compute infrastructure and their data centers. And really at the top of it, you see a consumer part. Of course, we have a service request. That's going to go down into a service interface. We have a service catalog component, which we see is very important. Then we'll start breaking up our services into virtual data centers. And again, I have several slides where I'm going to define some of this relatively quickly to get through it. And then we get into some of the virtualization layers like Cloud OS and cloud management, virtual infrastructure, and eventually physical infrastructure. And of course, the Cloud OS could then connect me to some external service providers as well if I'm trying to do things like bursting, for example, and being able to take on or move workloads or place workloads in different infrastructures. Starting at the top of the service manifest, this would be a standard template. It could be industry or de facto. In a perfect world, I would love everything to be an industry standard, but I think if we're working on all the industry standards we need for cloud to work, we'll be retired and our grandkids will still be working on those same things, right? So, some degree, some industry standards are good, like OVF is a good start, but we need other de facto standards too, where vendors just step up. They define some standard service tiers. They define some standards around security frameworks as well, and I'll get into some of those details in a little bit. Because what's important, if I'm thinking about hybrid clouds and portability, I want to be able to have consistent service delivery models that I can deploy either internally or externally. So if I have a model that specifies a specific recovery point objective, a specific availability level, for example, specific security boundaries, ideally I would like to be able to have that in a service manifest, be able to either just advertise that now, say to a public cloud provider, say, here's my requirements, yay or nay, can you do this? And there's some other parts that are emerging technologies, such as cloud brokers, that come into play here too. That's some other future-y stuff that's really just starting to emerge at this point. So the manifest will define my virtual data center configuration, my service requirements. Again, right now that's an industry standard. Open virtualization format is most widely used. There's other vendor formats, at least for metadata, which with VMware, of course, that's VMX. Microsoft would be VMC. Some examples of the kind of metadata we would need in that manifest would be the virtual network and storage configuration, CPUs, my service level requirements such as data protection, availability, business continuity, security, compute, I/O, and storage. And this is a work in progress. We're not there yet. I mean, ideally, we would like to say, Steve Herrod talked about having SLAs for virtual data centers on stage yesterday. We can't do it yet, and I'll tell you why. Because if you look at how vSphere is configured right now, the best that I can do when I get into things like I/O is I have storage and network I/O control. Storage and network I/O control doesn't give you a guaranteed quality of service. What it gives you is a relative priority. So it means I'm more important than you, so therefore I get more resources. But if we have a bunch of really important VMs on the same server, well, now they just have to get over it and share, right? But I'm not able to guarantee a specific amount of I/O, for example, for an individual VM yet. The storage and network I/O control in vSphere was a building block towards granular quality of service that I'll be able to do at the VM level. It's just you got to walk before you can run. Security zoning and auditing requirements. What are my actual security separation requirements? Do I have any data export restrictions that prevent where a virtual machine can go? This comes up quite a bit. I mentioned it in my last presentation. I've spent a lot of time in Canada this summer working with some of our Canadian clients where they're very forthcoming, saying, you know what? Because of the U.S. Patriot Act, we don't want any of our data south of the border. U.S. Patriot Act has been the best thing that could happen to a Canadian service provider because they're getting more customers. So, you know, they thank the U.S. government for that. That's terrific. But we even see it not just within the country, but even in Canada at the province level, where certain provinces do not want their data outside the province. So, again, being able to, you know, have metadata that can even tell me, and I'll get into some technologies that's fueling that later, you know, where my data can go and be able to actually audit that capability and authoritatively say, yes, here's where this VM is, here's where the data is at. That's some technology that is coming. Hardware-assisted virtualization requirements, I'll get into why that's important. Some folks will say within the cloud, all I care about is the app and the SLA. The infrastructure doesn't matter. I don't subscribe to that. There's a lot of reasons why infrastructure does matter, and I'll get to those. The service interface is what's connecting my consumers. Of course, we need an interface, right? I'm not going to, again, I told you I can give you the slides. For the sake of time, I'm just going to run through this pretty quickly. Obviously, this is what's connecting my consumer to the actual cloud infrastructure. That's also how different infrastructures are communicating to each other. Right, if I want to contact a public cloud provider, they're going to have an interface. If we're talking vCloud, they would be using the vCloud APIs so that I can communicate, I can broker a session, I can then, say, upload a VM to that infrastructure. We know the service catalog, and we're not saying that we need this huge ITIL-ish service catalog in modern cloud infrastructures. My colleague Cameron Haight, I think he had it just right. When you're talking about service and service catalogs, what we really need for cloud is just enough service. We can't get completely bogged down in every little nuance and every little detail of defining a service with 50 gazillion criteria, right? I mean, developers love it, but it's impractical. You know, Amazon is successful, and the reason these public cloud infrastructures are successful is because they dumb things down. They don't give you 1,000 choices. They give you a few choices. Pick the one that's best, and you have to move on. If the enterprise wants to be more efficient in how they deliver IT services, you have to sacrifice a little bit in terms of choice. And that gets down to even the service catalog and how you're advertising services to your consumers, you know, i.e. the business units. I don't want all of these different service capabilities. I want enough, just enough service for what my organization really needs. And my developers are going to have to choose. They're making those trade-offs today with public cloud resources. So you're not asking too much. The world is changing. We can't have custom everything. If they don't like it, tell them to suck it up. You know, too bad. Well, don't tell them that. You'll get fired, and you'll be like me and have to do some other non-user-facing job. Okay, so don't do that. All right. Virtual data center, talked about it a little bit already. This can be defined by a standard metadata format such as OVF. It's going to contain one or more VMs, distributed virtual switches. All the stuff in my traditional data center could be in that virtual data center. We need it that way for portability. If I'm going to move a service to the cloud, I need to be able to bring the storage, the compute, the security resources, any network controls that I have that have to be able to go with my applications. The virtual data center gives me that container to do that. You know, without it, I'm still trying to do instrumentation on somebody else's virtual infrastructure. I might not have the same controls. I might not have the same applications. So that might not work with all of my enterprise management tools, which is why having this type of encapsulation is very important. You know, are people doing all this today? Absolutely not. Are they thinking about it and building to it? Yes. So if I'm replacing, if I have a end of life on some hardware security appliances, for example, I'm using on my LAN, that's a great time to start looking at virtual security appliances that I can deploy to my virtual infrastructure and start managing that shift to the virtual infrastructure. Cloud OS would be responsible for managing the infrastructure as a service cloud resources. We have a lot of layers here. virtual infrastructure management, cloud management, the managed communication interface, which I'll get to. We have a couple types, which could be either the repurposed OS or the purpose-built. Repurposed would be like Hyper-V, for example, on Windows Server 2008. Purpose-built would be vSphere, for example, or a Zen server on Citrix, or open source Zen. Virtual infrastructure management does a bunch of stuff, right? Don't need to really get into all the details here. We're managing virtual data centers, high availability, the Cloud OS management database. So the equivalent to that today is the VMware vCenter database. Dynamic power management capabilities, OS metadata, high availability. So again, I'm making sure that if I do have a failure of that backend database, I have some resiliency there, or at least the server running that database. I have some security monitoring capabilities. For cloud management, we're doing a lot of stuff, optimization, chargeback, and service level assurance interfaces. Now, the chargeback one's interesting. Some clients that I work with, they're very, bullish on chargeback. They want to have this chargeback model in place, and they want to be just like a cloud. I work with other clients that say, you know what, we don't think we're ever going to get there. What we want to do is we want to understand what our data center costs, and we want to be able to do showback, so we can show the business units what actually a service is costing them or costing the company, so then we can start to prioritize. Because if you give the developer the choice, I have these 5 service tiers, the developer is always going to pick the best, right? I want full fault tolerance. I want everything. I want the platinum standard every time. That's because their application is the most important thing to them. They'll always pick that. So you have to show cost. That's hard, though, right? I mean, how many of you know what it costs to run a service in your data center? Anybody? Oh, I mean, you're not alone. That's the best part about VMworld is it's group therapy, right? So we all get together, we all got problems, right? So it's good stuff. It's good. We can get together and share that. And that's the problem. So when a provider or a vendor comes to me and says, we can have you cloud enabled in a month, I'm like, no, you can't. Because for most organizations, I'm not really a cloud unless I'm selling services, and I don't even know what it costs me to advertise those services. There's no way I can really legitimately call myself a cloud in a month. It's just not that easy. The organizations we work with on data center cost modeling and chargeback, it usually takes them 18 to 24 months to get there. To really get a handle on what IT costs and put some kind of chargeback or showback processes in place, it's usually about a 2-year project. It's a strategic investment that the organization is making because they understand that they need that information so they can decide where it's really best to run a workload. Do I keep it in-house? Do I run it externally? Right now, if it's anything sensitive, it's just in-house. That's like the default. And then I start using external because, I think it's cheaper. I don't know because I don't really know what it costs to run something internally. So again, these things take a while. So again, we can see the Cloud OS can do a lot of interesting stuff, right? Talked about chargeback, capacity and configuration management, another big deal. If I don't know how much capacity I have, it's impossible for me to automate provisioning. So I've worked with a lot of clients this year and last year. They've spent a lot of time deploying capacity management tools because, I can't think about doing services on demand unless I'm maintaining a spare capacity pool. And that's where capacity management is so important. Application-aware high availability. If I'm talking about a service, what I'm really looking at is making sure that my applications are available to users. If you look at VMware's high availability architecture today, we're treating a VM as a black box. So unless I have an OS blue screen, I really don't know what the application is doing, and I'm not just restarting a VM. So if an application hangs or a service stops, I'm going to need another operational management layer, like SCOM for Microsoft, for example, that can manage that and then restart applications. Workflow orchestration is a work in progress. There's probably 100 tools that'll say that they're an enterprise orchestrator today. Sure they are. They have a framework for orchestration, but what most of them don't have and where they're incomplete is having some pre-built modules that allow you to more easily integrate orchestration. So it's not just about provisioning a VM. It's connecting that to back-end approval processes. I might have to do some connection to a ticketing system, for example. I might have some chargeback and accounting processes that I need to plug into that too. And that's where these orchestration tools typically fall apart, at least right now. So that's a work in progress. And a lot of our customers that have done it, I have some that have already done a lot of in-house scripting and they've done some orchestration already, but it took a lot of internal work for them to do that. It was a lot of additional costs for them. Okay. Enterprise service management, this is our still top-level enterprise management. We still have a lot of things we need to consider, right? Orchestration, change control processing, security logging, business process management, capacity planning, application performance monitoring, service level auditing and reporting. Again, these are all things that are part of that maturity and getting there along the way. Like my app monitoring tools, oftentimes I can't use the same things I use in the physical world, because in the virtual world, I need to be able to take an application and see through all of these virtual abstraction layers to understand its performance nuances. So I want to be able to see through the hypervisor. I might have a network virtualization layer. I might have a storage virtualization layer. And I'm going to need that to be able to visualize a data path so I can start to look for potential problem areas. Okay, I want to move into our internal cloud maturity model and again, talk about some phases to get there along the way for the infrastructure authority. And I'm going to spend probably about 10 minutes on this, and then I'll spend the rest of the presentation specifically on the infrastructure authority. Like I said, I started working on this a couple of months ago with Cameron Haight, and we sat down and we said, how come nobody's put together a maturity model yet for internal clouds? And we drew the same conclusion. We said, it's hard. Of course not. So this is an attempt. I'm not saying it's perfect. I mean, we spent a lot of time on this. We got a lot of feedback from customers, and this was the result. But it's very hard to say, here's where you should be and where you should be then. So what we did was we split it into, 5 different maturity phases, ending at cloud-enabled, and then some things that you want to be doing along the way. And a lot of these tasks can be done parallel. Not saying that it's going to be linear. You might be reaching different points at different areas. But these are all things that are important to build out that cloud infrastructure. So just thinking about including virtualization in software procurement processes is an early important part of governance that sometimes folks aren't really thinking about. An example of that is when you're structuring RFPs for new software. What I want to do is include in that RFP a requirement that support for my virtualization software is included. And it's not even necessarily just to say that the vendor will support it. That's step number 1, right? And that includes client virtualization too. If I'm looking at doing client virtualization or virtualizing applications, if I'm looking at a new Windows app or I have a software renewal, I want to put in the RFP that vendor has to support, say, my app virtualization, i.e. ThinApp, for example, or AppV. They have to be able to support my virtualization environment too. And that's the way that we've seen that vendors have been pushed to supporting different flavors of virtualization, is by tying it to a sale. I mean, that's the easiest way. Even if they don't have a public support policy, time and time again, vendors have done one-offs in terms of support in order to satisfy a client and to win a deal. They'll do it, but you just have to give them a little bit of a push. So, early on, I have some pre-work that I'll get into, but we want to be deploying some at least lab automation. Talk about this for orchestration because it's an early way to start getting comfortable and building institutional knowledge about automating workloads and automating provisioning. I want to do that on lab systems first because it's not critical. It's not a production resource. This allows me to do something, and I'm going to be repeatable. It's going to be similar systems, and it allows me to really understand the software and build out some good processes. That's when you can then get into automating virtual machine provisioning, automating application provisioning, and then services. So I'll have sets of applications tied together that I'm automating, and then finally we can get into things like cloud bursting, where I'm moving workloads dynamically to the cloud. Again, that's a bit further out, based on consumption and resource requirements. Cloud bursting is interesting to a lot of our clients because there's a lot of organizations that have applications that they don't need to run on servers 24/7. They only need to run sometimes. They're very bursty in nature. So therefore, using a cloud service to run some of those workloads can make a lot of sense. Sometimes that's even just keeping those workloads in-house, but I'm repurposing some of my existing infrastructure. Might even be using features like VMware's distributed power management capability, so I'm either power stepping, reducing the power state of servers, or even taking those servers offline until that compute capacity is needed. So, service management, we're doing things like defining our service tiers. I'm going to get into some criteria for that, implementing service pools, showback, and updating some data protection, implementing or updating our service catalog, and then we get into infrastructure authority. On the management side, we're doing things like defining standard templates, deploying some of our essential services, making sure we're enforcing quality of service, deploying our virtual infrastructure appliances, then we're getting into virtual data centers at the end. And again, you see, some maturity for the types of applications that you're deploying on the bottom. So what are some of the things you need to do first before you even get to the maturity model or that first level of maturity? You need a cloud computing strategy. You need to map your security, app, identity, and information management to your cloud strategy. We want to assess and deploy our virtualization infrastructure, and we're deploying a bunch of stuff, managing our non-critical virtual workloads. I'm kind of trivializing this. This is all a lot of work, don't get me wrong. In the report I wrote, again, I think it's about 40 pages. This in itself is about, 10 or 12 pages, I think, just describing, what are the actual criteria for doing things like assessing storage or networking. Now, when it comes to cloud, this is, I mentioned this a little bit earlier. I wanted to give you some examples of why this is important. Things I hear is, all we care about is the app and the SLA. The provider gives me the virtual resources I need. Why do I care about the underlying hardware? Just for starters, hypervisor version is important. When I work with most large enterprises, if they're certifying an application stack, the hypervisor is part of the certification process. So for me to say that my app certified internally can just run on any hypervisor in the cloud and I don't care, that just doesn't fly for many organizations that have change control processes. That's not good enough. If I'm running, maybe I'm running early stages of test and dev in the cloud, but when it comes to staging, that hypervisor needs to match what I'm also running internally so I have that consistency and I have that assurance. Other low-level features is where this becomes important too. Things like extended page tables and rapid virtualization indexing. If you're not familiar with that technology, it's part of hardware-assisted memory virtualization. And why that's important is it allows VMs to modify their own physical page tables. I know, so what? You know, why is that important? Before we had EPT or RVI, memory access was managed using a shadow page table. So we had memory, which is designed to access RAM at nanosecond speeds, and it's being bottlenecked by a layer of software. The result was you had a lot of applications that just didn't run well in VMs. A lot of times people said, oh, it's probably I/O, maybe a CPU. I don't really know, but the app just stinks in a VM. It might have been a database app. It might have been like a Zen app server, for example. Once you got to a certain load, it just couldn't handle it, and bad things happened, right? The reason for that was, in almost every case, it was a memory bottleneck that wasn't actually surfacing to the application because the operating system's page fault handling capabilities was masking that. You had to actually go in and look for it. So if you use System Monitor and you were looking at page faults, you would see these ridiculous page fault spikes just doing simple things as easy as opening Windows Explorer, believe it or not. So bottom line is this technology solved that problem, and it's important because if I'm thinking about a virtual machine that, say, has 2 virtual CPUs and 8 gigs of RAM, I might be running an Exchange server in that VM internally, and it's great. I try to run that same VM as part of a business continuity exercise in the cloud, and it's running like garbage. You know, you're like, I don't get it, because on the surface, the VM settings look exactly the same. The issue would be that the provider is not running that VM on a hardware that exposes features like Intel's extended page tables. So that's an example of why, you know, that degree of infrastructure transparency is important. Because at the end of the day, it's not just about running the VM in the cloud, right? I mean, if it's dev and test, that's fine. I have to maintain my service levels and my expectations for my end users. The same thing can be said for technology like Intel TXT, which gives me a hardware root of trust. It allows me to definitively identify where a virtual machine physically resides in the cloud. So that's important too, especially when I'm concerned about data export restrictions. What Intel TXT doesn't do, and what the RSA proof of concept that rolled this technology out doesn't provide right now, is physical location identification for data. I can learn where the data is being processed, i.e. where the VM is at, but I don't know where the data physically resides. I don't have similar technology to establish a root of trust on a physical storage array yet. Okay, it's something we've talked to vendors about. They get it, just not there yet. Security policy and zoning enforcement, again, I might require separation of physical separation of security zones, depending on what my auditor is looking for. Reliability, organizations are willing to pay more for cloud infrastructure running on brands that they trust. You know, that comes up too. For some workloads, generic white box infrastructure, you know, SATA disk storage, fine. I'll take it because I don't really care. But for some of my critical production apps, I want to know what that infrastructure is because I want to have confidence in the provider's capability to actually uphold their SLA. That's a mistake I learned early in my IT career. I had to build all these servers, and I said, you know what? I'm gonna find the cheapest memory I can get, and I found this company that had the cheapest memory with a lifetime warranty. I'm like, I'm golden. This is great. So I bought it, put it in the servers, and I had like a 50% failure rate. And it's like, well, don't worry about it. It's a lifetime warranty. What do I have to worry about? Well, you know, the vendor wouldn't honor the warranty. So, you know, lesson learned, right? The hard way. Okay, certification. We talked about hypervisor being part of the application stack. So other things we're doing is mapping our security, application, identity, information management to our cloud strategy. All these folks are involved, especially if I'm trying to orchestrate things and move things around. I need to understand all of these interdependencies. This is why we just can't, you know, when we go to virtualization, the server admin just should not be running the world, or the virtualization admin shouldn't just be running the world. My security folks that have expertise in compliance and isolation issues and requirements around that have to have insight into what's going on in the virtual infrastructure, and that has to be part of the, you know, the maturity going forward. Okay, when we get into the first phase of maturity, talking about deployment capable, I'm going to go through these pretty quickly so I can spend the rest of the presentation on the IA. So our non-critical servers are virtualized. Our admins and developers are able to provision our test systems using a self-service interface. We should have some standard VM templates. I'm going to get into some details of what those templates are about, I think, on the next slide here. And some of our objectives, we're consolidating our physical servers onto VMs. We're defining our standard templates, service tiers, and we're going to start managing some of our non-critical workloads. Now, some issues with templates just to keep in mind, things like having at least a template for uniprocessor and a separate template for SMP VMs. That seems like a little issue, but the SMP HAL in Windows does require a bit more performance overhead than a uniprocessor HAL. So there is a slight performance difference if I try to use an SMP HAL on a single processor VM. Another one that I work on with clients quite a bit is on storage. Some of my clients, what we've done is separate their storage out so that when they have a VM template, it has multiple virtual hard disks. And they're always making sure they have a separate virtual hard disk file for the page file. And it sounds like, what difference does it make if I do that? Well, the issue is if they're thinking about using technologies like asynchronous replication later on. If I'm doing asynchronous replication, I don't want to replicate the page file. So I don't want to replicate a big C drive at the block layer where I don't have that page file exposed. Again, this isn't the case with host-based replication, but if I'm doing it in storage, this can be a problem for me. So when I have that separate VMDK, now I can do other things with it. With vStorage APIs for array integration, in time I'll have the capability to filter some of that stuff out on a shared LUN. But today, even if I wanted to, I can map those VMDKs to a separate LUN, not replicate it. I get a much better replication efficiency. Now, what's the net of that? If you do things like that early on in your template maturity level, the result is that if I never ever wind up using asynchronous replication, the end result is one more file in your VMs folder. That's it. But if I wind up turning on asynchronous replication later and I want those capabilities, I can do it non-disruptively. If I have to go back and create a new virtual disk file and remap a page file to that virtual disk file, later on, when I want to start leveraging things like asynchronous replication, what happens is to remap a page file, it's a reboot. I have downtime for all of my servers. So that's the drawback to thinking about templates and standardization later on is some of the smaller issues like that. Again, the templates is not just about the VMs. It could be about my physical hosts, shared and dedicated storage resources, virtual and physical networks, as well as security. Getting some of those standards in place early on makes it very easy to start to create service tiers and deploy services. Okay, the service tiers is setting my foundation for service delivery in the SLAs. Some common elements would be a relative priority. Again, that's what I can do in VMware today. I can't do true quality of service. CPU, memory requirements, availability requirements. So again, some workloads don't need high availability. Some do. You have to really start to piece and look at that. Some need continuous availability or fault tolerance. I don't want to just do a one-size-fits-all approach because that costs more money. What are my recovery time objectives and recovery point objectives? So again, that's helped me understand what type of data protection I need to place on that particular workload. Security zoning and isolation requirements would be part of that as well. Okay, the lab automation platform, I already talked about some of the issues there. Again, that's a good step towards being able to orchestrate IT and service delivery. We want to include virtualization considerations in the procurement process. Talked about these already. Talked about the RFP issue as one consideration. The other one, too, is when you're talking about support policies, don't let the vendor off the hook when they say they support virtualization. That's not enough. What you want to do is negotiate the support policy contract to have explicit language that identifies what would actually require a virtual to physical conversion. Because otherwise, it's basically at the vendor's discretion as to when they want you to reproduce something on physical. If you can say, well, if it's an issue in the I/O subsystem that we can attribute to virtualization, yes, I agree. That should be, reproduced on physical. If it's an application bug that has absolutely nothing to do with performance, no, I should not require reproduction on hardware. That's important because that can cost you money. If you're using technologies like plate spin convert, you're getting charged or you're paying per conversion. So there's going to be a cost that you would also have to absorb with the support incidents. Okay, operational ready. We're comfortable with our tools. We're starting to deploy different applications. Our admins can provision our production VMs. Our essential management services are now deployed. Our service pools are deployed. We have some underlying virtual and physical infrastructure that's highly available. Now we're, again, at this stage, we're doing things like automating VM provisioning. Again, I'm going quickly here just to get into the rest of the infrastructure authority content. Next thing we're getting into is deploying some of our essential management services. Talked about why things like capacity management are so important. If I don't know what my capacity is, then I'm not going to be able to offer really IT as a service because I don't know what I have available. Application-centric, some of my characteristics here now would be Tier 2 services and apps are virtualized. Our users can provision applications using a self-service web interface. We should have some chargeback at least in place for showback capabilities. Now, things we're doing here is we're doing some load balancing. We're virtualizing our Tier 2 apps. We're enforcing quality of service. We're automating app provisioning. We're updating and auditing our audit and accounting processes. Now, we also get into things like security, right? And the thing that we have to worry about with security is what we always have today, and that's a disconnect between security and operations. This is an operational fail, right? If somebody's drowning, I'm done, right? I can't get that life buoy out, and I'm stuck. But from a security perspective, this is a win, right? That buoy's not going anywhere. It's secure. It's great. So, and we have that today. If you think about it, it kind of goes against the grain with cloud because we have a lot of requirements for physical separation of zones, but it really impacts the amount of shared infrastructure we have. It impacts efficiency. It requires additional power and cooling costs. So there's a lot of additive cost for that physical separation that we have today. Now, so just some key characteristics of service-oriented. Our Tier 1 services are virtualized. Our end users can provision entire services, so that would be a multi-tier application stack. Our infrastructure is optimized to support multi-tenancy, so that's where we start bringing in things like virtual security appliances to help do some of that enforcement at the virtualization layer. Could be using some VMware technologies like vShield Edge that were just announced here to do that. We have a chargeback system in place as well. Things we're trying to do is optimizing for multi-tenancy. We're deploying virtual infrastructure appliances. We're implementing our service catalog, automating service provisioning, and we should have some standard models as well for service delivery. And that's important for hybrid clouds, so I can advertise those to the external provider, and I can use them in-house. So my service consistency is going to be there. And when we get to cloud-enabled, some key characteristics here. Now we're deploying our services to virtual data centers. So again, that gives me consistent security and enforcement and monitoring capabilities regardless of where that VM resides. My infrastructure is highly orchestrated. Our internal cloud is fully capable of operating in a hybrid environment. Things we're doing here, we're optimizing for portability. Now we get into the infrastructure authority, and we can integrate some policy enforcement with it. So to get into what that looks like, again, I think I've talked about some of the business drivers already for hybrid cloud, so I won't spend a lot of time on that here. Most folks are looking for business agility. They might be running out of capacity. Again, a lot of times this is cost, so I'm trying to move certain workloads to lower cost public cloud infrastructure, for example. It can be a cost-sensitive disaster recovery option as well. Characteristics, we have it's normal, it's on demand, it's elastic, we can pay as you grow, it's scalable. I should be able to automatically burst workloads between clouds. If we're talking hybrid here. It should be seamless to the consumer. The consumer doesn't necessarily have to be your user. It could be an administrator. So an administrator provisioning VMs shouldn't have to care what physical infrastructure that's going to. I should have policies that can automatically drive that. Based on virtualization technology, this should have a unified interface for the IT administrator as well as the consumer. So where do we use it? Talked about these already. Backup, data center migration, follow the sun, dev test is very common as well. And now let's get into a scenario so you can kind of see how this whole infrastructure authority thing would work when we get there. If a consumer is making a provisioning request, so that's going to come into our service interface. So again, I need an application or I need a service, right? I need a collaboration service that I want to deploy for users in my department. Once that request comes in, the cloud service interface would pass that request to the service manager or the orchestrator. So we see this architecture is evolving where I have a top-level orchestrator that's doing the movement, provisioning, retirement, et cetera. I have a second level that would actually be my infrastructure authority. So what I would do there is query the IA for available capacity. Now again, capacity doesn't mean just CPU, memory, et cetera. It means things like, okay, do you have capacity? Because here's the requirements. This service has these data export restrictions. I have these compliance and regulatory issues that have to be taken into account. I have this is my RTO and my RPO that's associated with it. So do you have the correct storage infrastructure to be able to meet that service level? If you do, then great. If not, so again, we're not just talking just pure capacity. We're talking about all these other constraints that are also important when I'm trying to deploy a service and be able to uphold a service level. So I check for capacity against the policy constraints for room to fit the new compute instance. If no room exists to place that instance, what I'm then going to do is contact an external cloud provider to see if the provider can fulfill that request. So when I'm building out my hybrid cloud, I might have one to a couple of different providers that I'm working with as part of my cloud ecosystem. Probably going to be one at first, depending on how many you trust. So if the external cloud provider can fulfill that request, and again, this isn't just about the performance characteristics, it's also about things, again, like security, regulatory compliance, et cetera. If I can fulfill that, then the vendor is going to see the space. I'll take that virtual data center. So I communicate back, again, from the interface back to the orchestrator. Yes, I can do that. The orchestrator would package the virtual data center. Again, or it could be a single VM, but it's probably going to be a VDC, collection of VMs encapsulated. That would be using like an OVF file as a transport for describing that metadata. I would send that to the external cloud provider. The provider would unpackage that virtual data center, deploy it to the cloud infrastructure. The provider would then confirm execution to that internal orchestrator, and once I have that, now I can confirm that back up to the actual consumer that made that initial provisioning request. So now my workload's not just deployed, but it's also in alignment with all of my policy constraints that I might have in place for a particular service. So what do we need? We need a lot of things to drive all this. Again, I talked about a lot of this already in the maturity model. The unified architecture, the infrastructure authority, license mobility, metadata standards, machine readable and negotiable SLAs, common API and data model, and finally infrastructure transparency, which we talked about already. Talked about the reference architecture, so I just put it up here for really just for reference sake at this point. So again, we need some commonality in between how I'm deploying virtual data centers internally versus the external provider. So I do have consistency. I mean, my monitoring, my security capabilities are going to be consistent regardless of where something physically resides. The infrastructure authority, again, it could be a central metadata store, or it could be an aggregator where I'm pulling different CMDBs and different metadata stores to align policy, again, with some of my orchestration requirements. It's going to map dependency to compute, memory, network, available storage, security and regulatory compliance, data, that would involve things like data location, latency requirements, protection, and recovery. So again, it's one thing to think, okay, well, I can move this service or this application to the cloud, but wait, the database that application relies on is in my Chicago data center. So therefore, I really need to make sure that application is deployed into the Chicago data center, because if it's anywhere else, I'm going to have latency issues and timeouts, and it just won't work. So again, that's an example of why I need to understand what some of the constraints are around an application. Environmental, such as power and cooling availability. One thing, if you haven't seen, that's interesting, Microsoft did some work on a project called Joule Meter. It's an in-guest agent that can detect power consumption at the VM level. So it's pretty interesting stuff. If you Google Joule Meter, you'll get to an article on a Microsoft website. Cost would be a factor too, of course. This can store and enforce my organizational policy, again, such as our security zoning rules checked before live migrating a VM. Do I have any site restrictions that would prevent VMs from migrating to a different data center or to public cloud infrastructure? It also gives me accurate capacity forecasts, because capacity just based on raw performance alone is always inaccurate. It's overly optimistic. If I have security constraints associated with where a workload can actually go, then I need to be able to factor that into my capacity forecast, because I might have capacity for a workload, but I may not be able to run that workload on a particular cluster because of security restrictions. License mobility. I've heard this in the past from some app vendors. Mobility is not an issue. The service provider can manage licensing for me. I disagree with that. I don't think that's scalable for cloud computing. Service providers have like a SPLA license agreement for select Microsoft apps. There's lots of reasons why that's bad for you. If you're a large enterprise, you want to be able to negotiate your own licensing policy and be able to move those licenses to the cloud, so that you can take advantage of your own EAs and your own negotiating power. You'll get a better deal than the service provider can. And also, the provider can only manage so many licenses. Most enterprises have thousands of applications they're managing. So to expect a provider to be able to manage your licensing compliance for all those is really just unrealistic. Our position is really device-based licensing is difficult to track. It's really impossible for service providers to scale, because I'm not trying to associate anything to a physical device. It should be virtual and virtual resources. So what do we have? I mean, virtual CPU, user, and seat licenses solve many of these mobility issues. Some physical constraints might be reasonable. The reason I say that is, ideally what we'd like is either licensing by virtual instance, virtual CPU count, or by like some type of user population. And most vendors are already there. Microsoft is, IBM is with their subcapacity licensing for ESX. The only vendor that's still licensed, the only major vendor I've seen that's licensing by just pure physical constraints today is Oracle. So it's Oracle licensing is by CPU core. That's been consistent with most of our clients. I have some that have site licenses with Oracle, so that's not a concern. But for others, that core-based licensing does present challenges, especially with mobility to cloud. Oracle does offer virtual CPU licensing in one instance. It's through their relationship with Amazon. If I deploy Oracle databases to Amazon EC2, I can license by a virtual processor. But that's the only exception today. Okay, and the other part, some physical constraints are reasonable. What vendors are worried about when you're deploying workloads to the cloud is follow the sun. So their concern is that I don't want you to just be able to ping-pong applications to different parts of the world and let them follow the sun and eat into my licensing revenue. I like selling you licenses for each geographical region, right? So, the vendors can either subsidize their licensing and raise the cost for everybody, or they're going to have some constraints on mobility, at least within a geographic region, to prevent you from doing things like follow the sun. So they have to protect their revenue streams too, which again, you could say what you want about the vendors, but I understand their position there. Metadata standards, OVF is a good start, but it's only useful for importing VMs. It's not used at runtime. Once a provider imports a VM using OVF, whatever kind of policy constraints that you actually put in there, like I can put service level information, security information, all sorts of goodness, RTO, RPO, that can all go in an OVF file because the metadata is extensible. But the problem is, as soon as I deploy that virtual data center using the OVF file is discarded as soon as the import completes. There's nothing left. So nothing actually persists at runtime that would enable me to query a VM and verify that it actually is meeting things like its availability requirements or its RPO requirements, for example. So that's still a work in progress at this point. Machine-readable, negotiable SLAs. The purpose would allow my infrastructure authority to programmatically determine a vendor's capabilities and negotiate terms on behalf of the consumer. This is way out there. This is what some of the work is going on with some of the vendors that are getting into the cloud brokering space. Put it in there, it'd be interesting. We don't expect dynamic negotiation to happen anytime soon. There's going to be a person making a decision and building that relationship with a provider, and then I can orchestrate around that once that's already set up. Common API and data model, we need this so my infrastructure authority can engage cloud providers. We have too many standards already, but this is really, where we're at. I mean, in terms of common APIs, there's not going to be an industry standard, obviously, right? But we will have some de facto standards. EC2, for example, vCloud, these are already de facto standards that are emerging. AWS is certainly a de facto standard in the cloud space. So we want to be able to write to a few of those, and that's fine. I don't expect us to ever have that single industry standard. The vendors can do a good enough job just driving some of their own de facto standards. Okay, just to wrap up before the Q&A, just some practical steps on what you can do. I put push for industry standards here, but what you're more concerned with is just pushing for some de facto standards. What I would like to see vendors like VMware do is make the providers in their vCloud ecosystem offer a core set of standard service tiers. So that includes a definition of availability levels, say RPO, RTO considerations, performance issues as well. So that might even include fault tolerance versus high availability. In other words, different levels of service tiers that I can use internally or externally. Right now, every service provider is rolling their own, so there's no consistency. So it makes it very difficult for you to automate service delivery in a hybrid cloud environment because I don't have that consistency. VMware could make some of those standard service definitions part of their vCloud certification program, and that would force the cloud vendors to at least accept some minimum standard templates. They can always innovate beyond that and add value there. There's nothing stopping them there, but at least have some level of consistency, which would be good for the customer to use both internally and externally. We need runtime metadata so that can identify our service level requirements. Again, we don't have that yet. An extensible metadata format for runtime, something that VMware has gotten some feedback on. We want to plug in architecture as well, such as standard XML templates so that I can plug in and extend the architecture. Because again, it's not enough for vendors like VMware to think to innovate around the cloud. There's plenty of vendors out there. There's IHVs, security vendors, network vendors that are doing some of their own innovation. And you want that innovation to be able to be plugged into your infrastructure and your management system without being bottlenecked by some very rigid extensibility requirements. This is just an example of some standard security models. Far from definitive. There's other work being done on this as well by the Cloud Security Alliance. If we had some standards for security models, what this does is it takes a lot of pressure off the security auditor. If I had standard security templates that I used in-house and I used the exact same enforcement and isolation capabilities external in the cloud, now it's very easy for the auditor to say, okay, here's the model you're using. Yes, this is compliant, or no, it's not. It becomes a much easier way to audit and enforce because I have consistency regardless of physically where a virtual data center resides. So just some rudimentary capabilities here. Dedicated physical host and virtual infrastructure could be one. Going down to level B where I have dedicated virtual and physical server infrastructure, but I'm sharing storage. So in other words, I have a shared array, but I'm just using a dedicated LUN for each zone. Level C might be shared virtual and physical infrastructure, where I do isolation by dedicated virtual security appliances. And then maybe level D is very basic and rudimentary. I'm not using any security appliances to do any separation, such as EC2 today. Defining standard service tiers, I might have 3 to 12 standard service models. In the examples today, you had 3. Or excuse me, the examples yesterday in the keynote, Steve Herod was talking about a platinum, gold, and silver SKUs. These are standard service tiers. So that can define availability, performance, security, data protection requirements. And this is just some examples of, again, it doesn't have to be this, but just some ideas here. Level 1, no HA, no data protection, multi-tenant shared infrastructure. Level 2, no HA. I have image-based data protection, multi-tenant shared infrastructure. Level 3, we have HA, image data protection, multi-tenant shared infrastructure. Again, we can spell them out a little bit further, but just to give you some ideas as how I can advertise, a core set of services to my organization that then they can use to deploy applications, et cetera. Okay, some attributes that would go in that service tier definition would include things like relative priority, CPU, memory, availability requirements, my recovery time objective, my recovery point objective, security isolation, zoning requirements as well, is all things that I can put into those standard service templates. Some tools that you need to do to get started, you need to select an enterprise orchestrator. I mentioned that basic lab provisioning is a good early step, but what you don't want to do, in my opinion, is buy a lab automation platform, i.e. VMware Lab Manager or VM Logix. Again, I'm not trying to kick sand on the vendors that do that. First of all, for Lab Manager, that Lab Manager functionality is being absorbed into vCloud Director. That's just where it's going. So Lab Manager, in my opinion, is terminal. It's going out the pasture, and it's going away, and you're going to have to migrate to vCloud Director at some point. The reason I mention that is you're better off with an orchestration platform that uses lab management automation as a feature. Because worst case scenario, if you go with the wrong platform, you still have your lab management solution. It's not a big deal. But if you pick the right one, now you already have your enterprise orchestration tool that you're growing and doing other things with besides lab management. It's just a more elegant, it's a cleaner solution long term. In our opinion, vendor selection is more important than feature parity at this stage. You don't have to go for the best orchestration platform. Go with a vendor that you trust, that can deliver on the roadmap, that you know is secure and is going to be around. That's more important than just going with a few different features that might be nice, but if you already know a vendor that you trust, say in a management space like Computer Associates is doing it, then away you go. Service catalog, again, is important, but again, we can't get too rudimentary into service definitions. Just enough service is really what you're interested in. Infrastructure authority like policy stores are not there yet, but will be in a couple of years. So again, it's something that you can start building towards and thinking about. And having some of those standards in place makes it easier to take advantage of that. You want to plan your infrastructure with a virtual data center in mind. The access layer will be virtual. That means your network, storage, and security groups should manage virtual appliances. My networking admins should be managing things like the Cisco Nexus 1000V, not my server admins. Server admins don't understand all the nuances of network switch configuration at a low level. It should be just like it is in the physical world, right? The network admins configure the port groups, say, okay, here's the port groups for these different apps. Go ahead and deploy. You just pick your port group and away you go. But the networking guys have control, of the network infrastructure, whether it's virtual or physical. They have the expertise. The process is going to be the bottleneck, not technology. It's people and process stuff that takes longer than anything else. So you want to work on chargeback procurement and things like that right now. So just to wrap things up, hybrid clouds are a work in progress. Cloud is about deploying services, not about deploying VMs. We need standards to make them work. Again, it doesn't have to be industry. It could be just de facto standards. There are some workable solutions today, but they're vendor-centric. Consumers often have to put those pieces together. You want to push your virtualization vendors for a holistic solution and infrastructure authority-like functionality. Standards around an API and data model. Again, I'm not saying industry standard, but at least standards that a vendor is using that's consistent between the vendor and the service provider. Consumers want to push the cloud vendors for transparency and support for a common API, data model, negotiable SLAs. Transparency is important. Don't just let the cloud vendor off the hook when they say that they're SAS 70 compliant. Okay, I was just talking about this in my security session last hour, and when they say they're SAS 70 compliant, I say BFD. Okay, great. Congratulations. Have a party. It's a self-audit, and oftentimes they're not transparent about specifically what they're auditing. So you want to dig in a little bit. If you ask them for transparency in terms of how they're segmenting, isolating security zones, if it's a large enough provider and they want your business, they're going to give it to you. And they do, but sometimes that negotiation can take a long time. Support for common API, data model, negotiable SLAs, even having support for some of those common service tiers that I talked about. Standardization matters. So far, every provider is rolling their own. That puts a lot of stress on security auditors to figure out whether a particular service is compliant or not. Service tiers, again, once we get into, say, very good, rich service provider certification, maybe that's not as big of a deal, but it still is today. With service tiers, portability is easier with standard service delivery models between internal and external infrastructure. And again, talked about standards already, not necessarily industry. There's just some references for some different docs. This is the bottom one is going to be published in about 2 weeks. That's the 40-pager on data center transformation that's ongoing. So we have about, looks like about 6 minutes left. So if anybody has questions, there is a microphone over here you can go to, or if you shout loud enough, I'll just repeat the question on stage. Yeah.
Is the IA something that you guys see as being a specific service, or is it just a collection of things? I guess maybe I missed that.
Yeah, that's a good question. Is the IA a specific service or a collection of things? We think it's an interface to the orchestrator. So when an orchestration tool queries for policy alignment, so I'm making sure that or policy dependencies. That it could be, some people say, well, maybe it says Uber CMDB. We say we doubt it. We think it's an interface to other CMDBs in your infrastructure that can map that alignment and then just basically handling the query. So it's kind of like an offload or a proxy, I guess you can say. And again, it really depends on the complexity of the enterprise as to whether that's just like a proxy-like device or if it's just a lower level single service catalog that just has some more advanced functionalities. Because some of the service catalog vendors that I've talked to about the concept, like NewScale, for example, said, yeah, we agree. And we're just trying to build that ourselves. So that would be like more of a one-stop shop.
And that couldn't be written into the orchestration itself? I guess I don't understand.
Yeah, it could be. It could be, yeah. I mean, and when that's a good question. Should it be written into the orchestration itself? When we initially spec the infrastructure authority, we were thinking, oh, it's just a do-it-all person. But when we started bringing the concept of vendors, the vendor said, well, you know what, we really think that it just gets too complicated and it's just too much. So we think it's easier to have a separation of duties because people are already deploying orchestration tools. So, and that's like virtualization. It's very sticky technology. So it would be easier just to plug in that infrastructure authority layer that the orchestrator could then exploit. Again, we're guessing at this point, it's going to be something like that, and we're going to start, I know we'll start seeing this technology in a couple of years. That's the indication I'm getting from vendors. Anything else right here? Great question, absolutely, yes. The business constraints are in many cases even more important. Yeah. Anything else? If not, I'll take your questions offline. I think I might even have a slide with my contact info. No, I don't. I have cards if you want one, or again, it's chris.wolf@gartner.com. If you need any information, I'll just send you a copy of the deck. Thank you very much.